This lab is about the drag force, and we're going to study the drag force or the coffee filter when it moves downward. And the drag force is essentially the frictional force due to air, and the direction of the frictional force is always the opposite the direction of the motion. So in this lab, the coffee filter will move downward, and the drag force is going to point upward. And the magnitude of the drag force could be either proportional to V or proportional to V squared. So this depends on the shape of the object, the air condition, and like temperature, density, and the mass. So we want to find out the drag force or the coffee filter. Does it follow the first relationship or the second relationship? And to find that, we want this speed to be constant. So the drag force depends on speed. If the speed equal to 0, the drag force is going to be equal to 0. So when you let the coffee filter start falling, initially the drag force is going to be 0. But when it speed up, the drag force will also increase. And it will increase until the drag force reach the magnitude of the gravitational force. And then the object will start moving at constant speed. We call that speed terminal speed. Okay, and this is the data table we are going to use to collect the data. And in this lab, we are going to use 5 filters. And for each filter, you're going to do 3 trials, determine the terminal speed and determine the terminal speed square. Okay, so this is the one of the plot I created, and we will just analyze the velocity graph. Let's take a look at this one. Not very good. I'm going to do another trial. Okay, so this one is better than the previous trial. Now let's look at the velocity graph. And this part, the coffee filter was at rest. Then it started falling down here. It's initially speed 0, so it's a speed up, speed up, speed up. And eventually it reached almost constant speed this part. And we will highlight this part. This is the part it was moving at the terminal speed. And I'm going to click stat. And the mean value 1.175. That's the average speed. That's the terminal speed for this one filter. Okay, and you will repeat this one with 3 trials for each mass. And after the one filter, and you add another filter, so to repeat the process for 2 filters and 3 filters. This is the data collected by one group of our class today. And with the one filter, this is the mass in kilogram, and they did 3 trials, and you will calculate the average. And with this is with 2 filters, different mass, 3 filters, and up to 5 filters. Okay, once you have the average speed, and you also calculate the terminal speed square. So basically, the square of the average go to this column. This is the data, and we're going to make 2 plots out of this data table. And the first one is the speed versus mass. The speed, that's going to be the average of this column, that's the y-axis, and then versus the mass. So this is the first plot, V versus mass. And the second one is the terminal speed square versus mass. So basically it will be this column, y-axis, and mass x-axis. So that will be the second plot. And so after you have the plot, you record the R square value. So basically R square tell us how good our data, or tell us the linear, so whether this line, this dot are linear or not. So if R square equal to 1, that means that the data are very good, perfectly linear. And if R square is like 0.1, 0.2, that means the data are not linear. And you're going to compare the R square. The plot with the greater R square will be a more linear line, and we will prefer that one. So and based on that, you can make the conclusion. So it will be whichever the plot with the greater R square, and that's going to be our drag force equation. So for example, after you get this data, and R square for the first plot is better than this one, so that means that this one is more linear, and therefore you will choose this equation. For the coffee filter, the drag force follow this equation. But if the R square is greater for this one, it will follow the second one. So the conclusion based on is based on your graph, based on the value of R square.